Social justice is at the heart of this study. There have been persistent inequalities throughout the decades. There have been inequality in access, participation, and science outcomes. And this has been to the disadvantage of students from low socio-economic backgrounds. The word "mo" itself was coined by a chemist named Oswald in the year 1900, and it's not different from the other SI units of length, mass, time, etc. The length is measured by a meter and the kilogram for mass, whereas the second is for time. These are all SI units. And we also say that the mole is socially constructed within the science community, because the chemists will want to look at the mole as amount of substance, and this I will explain later, which is equivalent to 12 grams of carbon 12. But the physicists, for example, Avogadro, want to concentrate on how many particles are in one mole. Whereas in the healthcare industry and pharmaceutical industry, where they deal with very small amount of substances, they want to concentrate more on the millimole. The millimole here is just a mole divided 1,000 times. It's similar to the meter divided 1,000 times to get a millimeter, or the kilogram divided 1,000 times to get a gram, or the gram itself divided 1,000 times to get a milligram, and so on. So we say the mole does not present itself easily for interpretation. It confuses both teacher and student, according to several research. The mole itself simply means a heap, like a heap of sand. And there have been several studies spanning decades on the mole, because it is such a crucial topic as it links practical science with theoretical science. Most of these studies have highlighted the fact that there are two principal methods of teaching and learning the mole, and these are procedural methods and conceptual methods, where the procedural methods are formula methods or mathematical methods, where you substitute into a formula and you get results. And the conceptual methods, where you rely on analogies and illustrations and things like that. So we're going to go into more depth on how the procedural method works, because it's crucial in this study. And this study highlights more the conceptual method, not the procedural method as previously said. I've illustrated here the two principal methods. Take, for example, if you're asked to add 3/4, that's 3/4 plus a half. Now, if you use a procedural method, you use a formula. You look for the lowest common multiple, the LCM, and then you arrive at that answer, 5/4, which gives you 1/4 and 1/4. But if I add context to it, for example, I say 3/4 of an orange plus half an orange. Now, this makes it a lot easier. Anyone can work this out and know that it will be 1/2 and 1/4 an orange. So, the procedural method, a child in upper primary will be able to do it. But with the conceptual method, even a child in lower primary will be able to figure it out. So this is crucial in this study, because we are proposing that the mole concept should be taught in school, right down to school, in primary school. Not procedurally, but conceptually. Because conceptually, everyone can figure it out. And you can only start learning the procedural method when you get higher, when you get to higher levels. And so, this will be highlighted. The conceptual method uses analogies, as we're going to see. Now, the conceptual method I've used above, using the orange, is help to bring the learning to the learner's experience. This makes the learning meaningful, as Usubel in 2000 explained and described. So we're going to use a couple of analogies, and I've developed a couple of analogies to explain the move. And one of those analogies is the experience in the West African market, the way the retail rice, gari, salt, and all those things you can call uncountable now. So in the West African market, as you can see there, you can see all the substances there. You can see the rice, the different types of rice, the gari, and the salt. But you also see the cup. That cup that they use to measure is the mole. It's an illustration of the mole, because it measures an amount of substance. In this case, the substance to the gari, to the rice, or to the salt. The same as we measure the mole, we use the mole to estimate quantities of different material, different substances, different chemicals, different substances. So as you can see here, the cup there represents the mole. Now, the housewife, and this will appeal to girls in West Africa because they do the marketing. The housewife might send the daughter to go to the market to buy cups of rice. And the housewife will be acting exactly as a chemist, because all the housewife is interested in is to work out how many cups of rice can feed the family. Now, a physicist will be thinking about how many grains of rice are in that cup. And they will even go ahead to develop a mathematical constant, like the Avogadro constant, to work this out. So analogies are important. And to conclude, a pharmaceutical scientist or healthcare professional will be interested in that cup of rice divided 1,000 times to get a minimum. So this will continue to illustrate the point about the mole. I used the word gari the past few minutes. I did not explain what it is. Gari is a type of fast food in West Africa, where you just need to add water to it and you have a meal. It depends on the kind of water. If it's cold water, you eat it straight away. If it's hot water, it turns into a kind of food and into something. So let me get us. So the findings of this research is that we are proposing that the mole concept, the mole, be taught in school, in primary school, the upper primary school, K stage 2, conceptually, not procedurally. Why is this? This is so because in this research, all the participants who came from the middle class background had earlier experiences of the mole in their academic careers. Say, year 3 or year 8 in secondary school, which in other countries you say Form 3, and in the US you say grade 7, and so on. So they, from middle class background, had this experience the mole from this early, right up to university. So according to Bodo, this has become second nature to them when they get to university. But this is not the case with students from low socio-economic background. In this study, they experience the mole mostly when they are doing the access courses or in the university. Therefore, the mole there is just first nature to them. So we are proposing that the mole should be taught conceptually from primary school. And as the example I've illustrated above, you will see that conceptually anyone can learn anything. almost all the previous studies on more concepts have been based on the scientific method of inquiry. And this is underpinned by the positivist paradigm, where reality or truth is embedded on the object under investigation, and therefore they are used mostly and entirely quantitative methodology. This study takes a different approach. This study is based on the narrative inquiry, which is qualitative methodology, and is based on the interpretive paradigm. Here, reality is multiple. So that's why we're lucky to have an increased variation of participants. So we had a wide range of participants. There were 12 in number out of 26 that responded to the recruitment questionnaire. So 9 of the students, they range from foundation year, BSc to PhD students, and in various fields. We had biomedical sciences, pharmaceutical, BSc chemistry, and PhDs in pharmaceutical science. 5 of those were in the focus group, and 4 in the one-to-one interview. We had 3 lecturers with a wide range of experiences, teaching experiences, lecturing experiences. One had lectured for 30 years in various universities and taught different science subjects. The other one has had experience of all 3 tiers of universities in the UK: Oxford, Manchester University, and London. And the other one is an organic chemist who's already involved in research, and one of the research students, PhD students, also took part in the study. So we're going to go into more detail of how we ask questions and why. We have to ask questions to help frame the narrative of the participant. Now, to determine the participant's social class, especially the students, and their habitus and forms of capital, we have to ask the participants the occupation of their parents and their parents' highest academic qualifications. And then to establish the field, we have to ask the students questions about their institution, how they studied the move, where they heard about the move, when they first heard about the move, if they've heard about millimoves, and all these questions to help establish the field. Now, for the lecturers, they gave us an idea of how the field operates. We asked them directly about their social class. They answered most of the time. They will tell us, like the lecturer who has had experiences lecturing all 3 tiers of university, Oxford, Manchester, and London Met. He described himself as working class, because in the UK, class is not defined by your academic achievement or resources. It's defined by your upbringing, the environment, your habitat, the environment where you grow up. Now, so to determine class, we ask them directly to the lecturer, and we also ask them how they learn the most. And some cannot remember how they learn the most, because most people teach the way they were taught. Wow. We ask the lecturers if they teach the historical context of the mode, and whether or not they use analogy to illustrate. So this question was to find out if they teach conceptually. So those who taught conceptually will say yes, they teach the historical concept of the mode, and they've used analogy, and they even go ahead to give us examples of analogies they've used. Like one lecturer, the one past 30 years experience, said 1 mole of water weighs 18 grams, which I totally agree. And I add that 1 mole of water is actually 18 milliliters, because 1 milliliter weighs exactly 1 gram. So these are all the questions we ask to bring out the narrative of the participant. Now, before I go into the recommendations and findings, let me just add that the procedural teaching teachers prefer because, according to Choi 2005, it says it is less time consuming, according to the teacher, and it's easy for accountability, for teachers' accountability. Well, that's what they claim. Now, those who teach only procedurally, in answer to the question if they teach a historical context or they use analogy, those who teach only procedurally will say no, because they don't think that it adds to the gravitas of the whole thing, the whole concept. Or they might say the students are not interested in those kind of methods. That's why I just want to make that clear before I go into recommendations. Now, we have recommended that the mode be taught in school. And we arrive at this conclusion because if you consider the habitus, at least one participant in this study learned about the mode and minimum from the parent. Because her mother has a doctorate degree in pharmacology. And she has learned about the mode and minimum from home. And her inclination towards the sciences, because she's now studying biomedical sciences, is because of the home socialization. Because the books, the science books left around at home. Because even the private school that she went to in Germany, they tried to reorient her towards the arts. But because of what she's experienced from home, she took up the sciences instead. So this is where we can see, according to Bourdieu's theory, where habitus plays a direct impact on participants' more concept experience. And this is because of the home socialization. So we are saying that Bourdieu said the field is porous. And the field, because it's porous, can be changed, can be influenced. So we are saying that these changes can only come in the field. And we are recommending that it should start from primary by teaching the children conceptually, and they should learn it at the same time as they're learning the other units of measurement, the other SI units of measurement, and in relation to those units. And this recommendation is unique to this research. So, as Bourdieu said, the field is second nature to middle class students. And it's not only second nature, it's multiple nature, because they experience it several times. They've gone across the mode in several different levels. So we are saying that this can become common knowledge as well, because if it starts from school, the learners today will become the parents tomorrow, and the critical mass will be built where the habitus can help to reshape the students' more constant experiences. That is a recommendation for this research, this study, and it's crucial. So there's nothing wrong in a child learning that 1 mole of water is 80 milliliters. They can measure it, they can play with it, they can subdivide it. 1 mole of common salt is 58 grams. They can play with it, they can touch it, and they can even give us examples of, other moles, other common substances, and 1 mole of those. So that when they get to higher studies, then they start to understand why is it that 1 mole is 18 grams. Because the oxygen atom, the atomic mass is 16. And why the 2 hydrogens are 1 gram each? Because they have only protons, they don't have the neutrons. And students can master these things when they get to higher levels, so that the mole will become second nature or third nature or multiple nature to all the students, not only some. And this is a recommendation of the study. I would like to take this opportunity to thank all my supervisors. They are both scientists and social researchers. First is Associate Professor Sheila Hughes, Dr. Mary Jane Foucault, and previous to that, we have Dr. Rosanna Perez, sociology, Dr. Alison Hoover, and before them, Professor Carol Leth, now retired, who grounded me on the concept of social justice. Thank you.